Today we'll lock down our Azure VM and refactor our Terraform code using modules, and the way it's done in real production environments. If you are preparing for cloud engineer interviews or you want to work in real world Azure projects, these concepts are essential. So let's move to our goals for this video. As you can see, we evolve our Terraform infrastructure step by step. On the left side, our code structure has matured. In this video, we are going to take it further by implementing Terraform modules, just like real production environments. On the right side, we've already built the foundation, like resource group, virtual network, and our first virtual machine. Now it's time to make it secure. We'll implement network security groups properly and also restrict access using Azure Bastion. This is where infrastructure becomes production ready and where you start thinking like a cloud engineer. So let's move to the next slide and talk about how we can secure a virtual machine. Securing a virtual machine is not just one setting. It's a layered approach. In real production environments, we apply multiple security controls together. First, reduce internet exposure. Avoid assigning a public IP when it's not necessary. The less your VM is exposed to the internet, the smaller your attack surface. Second, filter traffic using network security groups and firewalls. Control inbound and outbound traffic carefully. Define exactly which ports and protocols are allowed. Everything else should be denied. So we're gonna use the network security group in our Terraform code in this video. Third, use a strong authentication. Always prefer SSH keys instead of passwords, and disable password login whenever possible. Fourth, use Azure Bastion for secure access. Instead of exposing SSH or RDP to the public internet, access your VM securely through Bastion. And also we use Bastion and we describe it in this video in our Terraform code. Fifth, enable monitoring and threat detection. Use logs and security tools to detect suspicious activity early. Sixth, keep your operating system updated and patched. Many attacks target outdated systems. So last week, one attack happened to our customer because of being outdated, And seventh, protect your data. Encrypt disks and manage secrets securely. And finally, always enable backup and test your restore process. It's so important. Security also means being prepared for failure. In this video, we'll focus on two of these layers: network security groups to control traffic and Azure Bastion to remove public SSH access. Before we move on, let's quickly understand how a network security group works. An NSG is basically a firewall for your Azure network. It sits in front of your virtual machines and decides what traffic is allowed and what should be blocked. When traffic arrives, the NSG checks things like the source IP, the destination, the port like SSH on port 22, the protocol, the direction of the traffic. Based on that, it either allows or denies the connection. You can attach an NSG either to a subnet, which protects all VMs in that subnet, or to a network interface, which protects just one VM. In our case, we'll attach it to the subnet, so it controls access to our virtual machine. So the traffic flow looks like this: internet, public IP, NSG, subnet, and virtual machine. Now, instead of exposing SSH directly to the internet, Azure provides a service called Azure Bastion, which allows us to connect to the VM more securely. So let's quickly look at how Azure Bastion works, and then we'll implement everything with Terraform. Normally, if we want to connect to a VM using SSH or RDP, we have to open ports like 22 or 3389 to the internet, and that obviously not the most secure approach. Azure Bastion gives us a better way to do this. It basically acts as a secure entry point inside our virtual network. So instead of connecting directly to the VM, user connect to Bastion through the Azure portal over HTTPS on port 443, and that connection is secured with TLS. Bastion itself runs inside the virtual network in a dedicated subnet called Azure Bastion subnet. Once the connection reaches Bastion, it then connects to the VM using its private IP address through SSH or RDP. So the VM doesn't need to expose those ports to the internet anymore. So this is much more secure way to manage our virtual machines. Now that we've looked at the Azure side of the security, let's see how we can implement this setup using Terraform modules. Let's quickly talk about Terraform modules. A module in Terraform is basically a way to organize and reuse infrastructure code. Instead of putting everything in one big file, we split infrastructure into smaller pieces, where each module handles a specific part of the environment. This makes the code cleaner, easier to maintain, and easier to reuse in other projects. In this project structure, the main Terraform files are at the top. Things like provider.tf, main.tf, variables.tf, and outputs.tf. These define the overall configuration and call the modules. Then inside the modules folder, we have separate different components of the infrastructure. For example, we have modules for networking, the virtual machines, Bastion, and the NSG. Each module usually contains its own main.tf, variables.tf, and outputs.tf. So everything related to that component stays together. So this keeps the project well organized and scalable. Now that we understand the structure, let's go to the Terraform code and see how we implement these step by step. Here's the strategy. We deploy the same infrastructure in two phases. Phase 1, SSH is open. We can connect from the internet. This is the insecure state. Phase 2, we lock SSH down so only Azure Bastion subnet can reach the VM. The key idea is we don't destroy and recreate the VM. We simply change the NSG rule to move from insecure to secure state. Let's move to VS Code to check our Terraform code. So here we have modules for Bastion, Linux VM, networking, and NSG. As I mentioned before, this gives us three big benefits. The code is easier to read, each piece is reusable, it's easier to scale later, like adding more VMs or more subnets. Let's break down our code and check what's going on here. Provider.tf. This tells Terraform we are working with Azure and we define a compatible provider version. Next, we define variables. And if you notice, all of them are for our root in Terraform code. These are not part of our modules. So we define variables. Variables make our code flexible. Instead of hard coding names and IP ranges, we define inputs. And the most important, And the most important variable in this video is SSH source CIDR. That variable controls who is allowed to SSH into the VM. Let's move to Terraform.tf. This file is shared in both phases, so it contains region, VNet CIDR, and subnet CIDR and VM login. If we check phase1.tf, we purposely allow SSH from the internet. This is the insecure state for demonstration. And this source address prefix is 0000/0, meaning access from anywhere. We will run our Terraform code with phase 1.tfs to create an insecure VM, and then we're gonna run our Terraform code with phase 2.tfs, and you will see how we do it shortly. So if I open phase 2.tfs, we secure it. Now SSH is allowed only from the Bastion subnet, so internet SSH will fail. And this is a real Terraform basic practice. We change only what we need, we input variable, and Terraform updates the NSG rule in place. And finally, main.tf is the orchestration layer. It creates the resource group and then calls each modules. Modules are like building blocks. Terraform runs them in dependency order automatically. So if you check the main.tf, you can see we call all of the modules here. Networking runs first because VM and Bastion need subnet IDs. NSG attaches to the workload subnet, so it affects the VM. Let's move to the networking modules. So if you check networking modules, you can see the network module creates the virtual network and two subnets. If I check the variables, and so let me check it here. So the first subnet is for workload, and the second subnet is for Azure RM subnet. So it's for Bastion subnet, which must be named exactly Azure Bastion subnet. And if we open this module, Linux underline VM, the Linux VM module creates a public IP, a network interface, and the Ubuntu VM itself. In phase 1, we want SSH to work, so the VM has a public IP and we allow port 2020 through NSG. Later, in phase 2, we keep the VM the same but block SSH from the internet. Unlike my other videos, you can find the full Terraform code in the comments, where I've shared a link to my GitHub repository. And also this module, Bastion, Azure Bastion, is a secure way to connect to VM without exposing SSH to the internet, as I mentioned before. Bastion runs inside our VNet and we access it from the Azure portal. So even when SSH from the internet is blocked, Bastion still lets us connect securely. And if you take a look at this module, NSG, this is the most important module in this video. The NSG module creates the network security group, an inbound rule for TCP 2.2, and then associates the NSG to the workload subnet. And the rules source is controlled by SSH underline source underline CIDR. This is exactly how we switch between phase 1 and phase 2. So let's run it. Okay. Terraform init. So I'm gonna pause the video when I'm running the code, so we don't need to wait to see the results. So Terraform init is done. Let's go to Terraform -var, -var -file equals phase 1.tf vars. First we deploy phase 1. So after phase 1, SSH should work from a laptop, and I'll check and I'll verify and I'll show you. I forgot to put the plan here. So as you can see, it shows us it's gonna add 12 things to our Azure. So I'm gonna run apply and pause the video, and I will show you what will happen. Alright, phase 1 is deployed. Now I'm going to verify that everything is working correctly. Since in phase 1 the NSG allows SSH from the internet, I should be able to connect to the Linux virtual machine using SSH. Let's take the public IP of the VM, that is 21.51.225 and 184, and try to connect it from the terminal. So I'm gonna type Azure user @ the public IP address. So I'm gonna say yes. We have our password here, and I think it's here. So I'm gonna copy this one and paste here. Okay, so you can see I connected to our virtual machine. So I'm gonna run phase 2, and I will verify that after running phase 2 I cannot connect to the VM through SSH. Let me exit from our Linux VM. So I'm gonna run phase 2. So I'm gonna confirm it. Alright, phase 2 has been applied. At this point, the NSG rule has been updated to that SSH access is allowed only from the Bastion subnet. So if I try to connect to the VM directly using SSH from my machine, the connection should fail because the internet is no longer allowed to reach port 22. So let me do it again. It's gonna time out and it doesn't let me to connect to the Linux through SSH. As you can see, connection timeout through port 22. However, I can still connect to the VM through Azure Bastion. So we are at Azure portal. Let's go to virtual machine. This is our virtual machine that we created. So if I go to connect and then Bastion, you can see we can use the Azure user and then copy our password. I can connect to our Linux virtual machine through Bastion. Alright, so in this video we secured our virtual machines using NSG and Azure Bastion, and also we organized our infrastructure using Terraform Modules. In the next video, as you can see, we'll move to the more advanced topics like Azure Policy and Terraform State Management in Azure Storage. So I'll see you in the next part of this series.